Welcome to the CAD Office Training Guide series for F.Connect for OpenBridge Modeler. My name is Joel Gutierrez and I am a structural engineer with WSP USA. In this video, we will be covering exercise 5.9 from the Bridge Design 3D and Plans course guide. This exercise demonstrates how to create an approach slab for a bridge model. Let's get started. To start this exercise, I'll give a little bit of background information on different modeling techniques that can be used in the process of approach slab modeling. Then I'll start going step by step through exercise 5.9, first by creating an approach slab. And for this exercise, we'll be using flexible pavement, meaning we will need to accommodate an asphalt overlay. We will also be placing a sidewalk on the left side of the bridge, and then we'll also place barriers at either side of the bridge. You'll notice that we'll use different barrier templates for the overlay portion versus transition portion of the approach slabs. Now let's discuss a couple of ways you can model an approach slab. The two main alternatives that we have at our disposal are the Place Approach Slab tool and the Place Deck tool. So the first alternative mentioned was the Place Approach Slab tool. This is an approach slab specific tool. So this method does not create any additional support lines, and instead it creates one approach slab reference line, and that's going to be associated with an existing support line that has already been modeled on the bridge. So a couple of things regarding this reference line: it must be defined at the start or end of the bridge, and you can only place one line at either end of the bridge. Then it is defined by either a station or a specified offset from the selected support line you've chosen. This tool is very useful for relatively simple and uniform approach slabs. So for instance, how FDOT uses rigid pavement approach slabs where you have no skew at the ends and a relatively uniform cross section. Or if you have an approach slab that has very minimal geometric constraints, so there's no bend points or a lot of variance in the width or thickness of the approach slab. It gets a little bit difficult to model any kind of approach slabs that are multi-segmented. So for instance, when we're trying to model the flexible pavement for the FDOT, where we have to accommodate a different thickness, while you can still do it, and you can say you'll just define an offset from a support line. Sometimes if you have a skew or a curved alignment, it makes it so that it's a little bit difficult to control the geometry of the interface between those two segments. The next tool we have at our disposal is the Place Deck tool. This method, instead of using the approach slab reference line, you would actually use additional support lines. This is the alternative we're going to be using in this exercise specifically, so you'll see it more in play. But essentially what you'll do is place as many support lines as you want, as opposed to the solitary reference line that you use in the approach slab tool. So that allows you to break up the approach slab into several different segments if desired. So because you can do multiple segments with this tool, it's much more conducive to modeling the flexible pavement for FDOT and more conducive to a more complex geometry. So if you have a lot of bend points or anything like that. There are a couple of minor drawbacks to using this alternative. First one being, since this is not an approach slab specific tool, when placing an approach slab using this tool, the user just needs to be more aware that they're selecting the correct feature definitions. Because this is the Place Deck tool, there will be deck feature definitions made available alongside the approach slab feature definitions. The other thing to consider is that because you are placing additional support lines, the program will consider each new segment that's placed between those support lines as a new span in the bridge. While not really a major issue, it can just get a little bit confusing when reading reports because the nomenclature will start with the approach slabs as spans 1, 2, etc. So the user just needs to be aware of that potential mix-up and adjust accordingly when reviewing the reports. So now we're going to start stepping through exercise 5.9. First thing we need to do is have open our 5.9 underscore begin DGN. So I have that open here, and as I previously mentioned, the alternative that we're going to use for the approach lab placement is going to be the place deck tool. So the first step in that would be placing our support lines. So to do that, let's go up to our home tab, which we should already be in, go over to the support line group, go to place, click the drop down and click on multi. So once our place multi support line window pops up, we're going to start locking in some of those inputs here. So first thing would be to lock our length. We're going to go ahead and set that to 54'3". Next, we'll set our offset to negative 18 feet 3.5 inches. We're going to update our start station. We'll toggle those on to lock those. We'll set our start station to 2019 plus 76.96. And then we'll set our end station to 2020 plus 06.36. So for this bridge, we're going to be modeling flexible pavement, meaning we'll need two segments for the approach slab. So we'll have one segment be the asphalt overlay segment, and then one segment will be the transition segment that is just going to be concrete all the way through. So to accommodate two different segments, we'll need two additional support lines. So we'll leave that as is. And then we'll make sure that the direction mode is set to direction. Toggle on your direction here to lock it and input 71 degrees, 54 minutes, and 1.8248 seconds. Last thing would be to confirm that the feature definition is set to support line, but that should already be the case. And then we're going to start clicking through to confirm all of our inputs that are in the window. So first thing would be to enter the start location. We'll left click to confirm. Next will be to enter skew. We're going to left click to confirm that as well. And the last thing will be to enter end location. We'll left click one more time, and that should lock in all of our selections. And that will open up our place multi-support lines window, summarizing all of our inputs. So within here, we can make edits to all of our inputs. For this, however, all we're going to update is our names here. So for the first one, we're going to rename that to app slab 1 begin. And the second one, we will update to app slab 1 transition. That transition support line is going to mark the point where we change from the asphalt overlay segment to the full depth concrete segment. So once we have that all set, we will click OK to confirm it all, and that will lay in our new support lines at the beginning of the bridge. Okay, so with our approach slab 1 support lines all set, the next step is to repeat that process just for the approach slab 2 support lines. So we'll leave our place support line window open, but we're just going to make a couple of changes to each of the inputs there. So we'll leave the length as is, as well as the offset. All we really need to do is change our stations. So we'll set our start station to 2023 plus 36.36, and our end station will now be 2023 plus 65.8 or 18. Okay. Everything else should remain the same, and we can go through the process of confirming those inputs. So we'll just left click to confirm our start location. We'll confirm our skew with another left click and one final left click to confirm our end location. That'll pop up our window again. All we really need to do here again is to change our names. So we'll go with app slab 2. So this first one is going to be the transition support line this time because it'll be going in reverse. And the second one will be app slab 2 end. And we'll click OK. So now you'll see we now have all of the support lines we need for our new approach slabs. So with all of our support lines now set, the next step is going to be placing our actual approach slabs. So to start that process, we will right click to get out of our support line tool, and then we'll go up into remaining in the home tab. We'll go up to the superstructure group and click on the place deck tool. Now we can get started on our begin approach slab here. Now, as I said, we're going to be modeling our flexible pavement approach slab. So this first segment will have a negative vertical offset. So to accommodate the 1 3/4 inch asphalt layer, we're going to set our negative vertical offset to be negative 1 3/4 inches. Okay. And then we need to select an actual template. So much like we did in the deck placement exercise, we're going to go ahead and select a template name here. Once your template selection window opens up, we'll go to the template that we created, _tr dash app slab, and click select. And now we'll just confirm some of these inputs in the window here. We have no changes to our station offsets and no horizontal offset that we need to change because we already tailored our template to this specific bridge. So only thing we need to do is match some of the other inputs. So we'll change our max distance between sections to be 1 foot, and then we'll change our right start break back distance to be 1.5 feet. So that is going to model a break back on the right side over at the beginning of the approach slab. And then we're going to go select a deck material. So we'll click on the ellipses next to deck material, and we're just going to go over to the approach slabs pay item here. And click select. And then this is what I was referring to earlier. Since we are in the place deck tool, we are not using an approach slab specific tool. We do need to make sure that we're selecting the correct feature definition. So we're not going to select concrete deck here. We are going to select approach slab. And then you can also see we do have a couple of additional feature definitions for the actual asphalt pavement there. So once we have all of our information correctly input into the place deck window, we're going to select our support line for the beginning of the approach slab. So that's going to be the app slab 1 begin. And then the second deck boundary is going to be our transition support line. Then do we want to add any constraints? We're going to say no. And now you'll see that we have our new approach slab component there. Now we'll repeat this process for the transition segment. So for this, we need to make a couple of revisions to our inputs. We're going to remove the vertical offset here. We'll set that to 0 because we no longer have any kind of asphalt overlay. And then we're going to make some edits to our breakbacks. We'll no longer have a breakback at the start on the right side because that's going to bump up against where we have our previous template. And now we just need to set our end breakback distances. So on the left side, we're going to set that to 1 foot 1. And on the right side, we'll set it to 1 foot 6. Our deck material can stay the same. It's still going to be that approach slab deck material. And then our feature definition is already correctly selected as approach slab. So next, we'll just select our two boundaries. We're going to click on the app slab 1 transition as our first one, and then our front face of back wall end bent 1 as our second deck boundary. Do we want to add any constraints? We're going to say no. And now we'll have an additional component there. So now with both segments of our approach slab placed, you can see we have our 28-foot asphalt overlay segment and our 2-foot transition segment. We'll take a look at the isometric view. You can see that the asphalt overlay segment is vertically shifted downward because we had that vertical offset, and the transition segment is still at the same profile grade elevation. However, you'll notice they both still have the same thickness. The next step is going to be making this transition segment thicker to match the bottom of the approach slab on the asphalt overlay segment. The best way to do that will be going through the variable constraints. However, we cannot change any variable constraints until after we've assigned super elevation to the approach slab. So if we decided that we are going to change variable constraints first and then assign super elevation, it would wipe out any changes we had made in those variable constraints. That's why before making any changes to our variable constraints, we always need to make sure that if super elevation is present, that gets assigned first. So I'll begin that process now. We'll return back to the first window here. I can right click out of the place deck tool, and then we're going to verify that we have on our super elevation reference. So go up to the reference window. We'll verify that the super elevation model is turned on from our roadway file, and it is. And then you can tell that by seeing the green outlines here. This is going to be your super elevation corridor. Next, we're going to click on the Assign Super Elevation. We'll select our super elevation section, so that'll be the green outline here. You'll right-click to confirm, and then we're going to select the candidate that we want to have the super elevation assigned to. So first we'll start with our asphalt overlay segment. Then you should have a window pop up showing super elevation assignments. So we'll make a couple of quick edits to the super elevation assignment window. We'll start by changing the template point on lane 1 to 1. We'll change our pivot point to be 0.0, and then we can change, now that that's no longer selected as the pivot point, we can change template point back to 0.5. So when looking at the super elevation assignment, this has already been touched on in the place deck exercise, but just to reiterate, the pivot point is always going to be where that super elevation is pivoting, and the template point is going to be the outside portion of that super elevation assignment. So now we can go ahead and click OK. Let's go ahead and click yes to continue. And we should have our super elevation assigned to that segment now. So last step for assigning the super elevation will be to do the transition segment. So we'll click on Assign Super Elevation again, click on the super elevation section, and then right click to confirm. And we're going to go back in and select our transition segment there. Once again, we'll update this to 1, change our pivot point to 0, and then change our template point back to 5. You can click OK and yes. And now we've successfully assigned our super elevation to the approach slab. With our super elevation now assigned, we can successfully go in and change our variable constraints. So we are now able to change our thickness for our transition segment. So we'll go ahead and select our transition segment and then open up the properties window if you don't have it open already. So that can be accessed through the Home tab in the primary group and then clicking on the properties tool there. You should now be able to see all the properties for that segment. We're going to go over to the variable constraint, click on select to edit and click the ellipses there. So now with the variable constraint window opened up, you can take a look at the fact that our super elevation has in fact been applied, because you'll notice that the left slope and right slope are toggled on to active, meaning that they're being overridden by the super elevation that we assign to it. And then now the next thing that we want to activate is the thickness, because we're going to go in and manually override that. So toggle on the thickness. You can go ahead and click on it. And the mode that we're going to use is support line. We're going to run it from the approach slab 1 transition support line. And then you can go ahead and click on the plus button here. Once you have input showing up here, we can change our start value to 1 foot 1 3/4 and the end value to match the same. So now we can click OK to confirm. And I'll go back into our 3D view over here, and you'll notice that both portions of the approach slab are now at have the same bottom level. So that means we've correctly set our thicknesses and offsets. Now step 16 is just going to be following all the steps we have for the rest of the exercise 2 through 13, but we're going to do it on the end approach slab. So this portion I'm going to run through a little more quickly. So I'm going to start by going to place deck. I'm going to do the transition segment first. So we'll do no offset, set our breakbacks. Everything else should be the same. And then we'll do our asphalt overlay segment. Next step will be to assign our super elevation. Once again, select our candidates, make the appropriate changes. Click OK. And assign the super elevation to our asphalt overlay segment as well. Click OK. So now we've got that in place. We'll change our variable constraints for the transition segment again on the end portion. And click OK. Now we should be all set with our approach slabs. We'll take a look at that from a 3-dimensional view. So there's our begin approach slab, and here's our end approach slab. So now that we have both approach slabs placed, we'll return back to our plan view and start placing our sidewalks. So the sidewalks are going to be placed using the barrier tool. That can be found up in the Home tab under the accessory group and place barrier. So we'll go ahead and click there. The first thing we're going to do is select which candidate we want to place this sidewalk on. So we'll start with our begin approach slab, the asphalt overlay segment. So I'll click on that. Then we'll need to set all of our inputs. So we'll change the template that we're using to be the sidewalk template. We'll go into the sidewalk folder. And since we're going to be placing this on the asphalt overlay portion, we're going to use the underscore flex AP version of the template. So since it'll be the left-sided sidewalk, we'll click left sidewalk underscore flex AP and then click select. We'll set our offset to 0. Set our burial material. Make sure that that is correctly set to the class 4 superstructure concrete. Go ahead and click that, click select. And then lastly, we need to make sure that our feature definition is set correctly to the sidewalk feature definition. And before we move on, make sure that your cut orientation is going to be follow skew. That's just going to dictate whether or not the beginning and end of the sidewalk is either skewed or normal to path, which would be squared off. So we'll leave those both to follow skew. With all of our inputs now set, we'll right click to end our selection and left click to continue. That'll have your path selection window pop up now. So here's where we're going to tell the program where we want our sidewalk template to run along. So we're going to use the select guideline from list option, and then we're going to choose which point on our approach slab template that we want our sidewalk to run along. So since this is the left sidewalk, we're going to do 0.5, which is at the left end of the approach slab. So we'll click that, click OK. And then once you see the blue check mark up here in the candidate, you'll say OK. And that should generate your sidewalk on the first portion of the approach slab. Now, if you zoom in, you'll notice that the approach slab sidewalk is not aligning exactly with our deck sidewalk. That's because we'll need to change the width of the approach slab sidewalk. So we're going to do that by accessing the variable constraints again. We'll go ahead and click on our sidewalk, open up the properties tool again if you don't have it open already, so that will once again be in the primary group of the Home tab. And then we'll access the variable constraints by clicking on the ellipses there. Next, we'll click on the sidewalk width, set that to active so we can actively change that. And then we're going to use the support line mode and change the width starting at the AppsLab 1 begin support line. So we'll click the plus sign and change those values now to be, I believe it's 4 feet wider. So we're going to set that to 11'1" for both the start and end values. And once you have that set, you can see graphically it's now set up here to 11'1", and we'll click OK. And that will update your sidewalk width. So now that we've run through how to do one sidewalk, we'll do the remaining 4 segments. We still need one more sidewalk on the transition segment of the begin approach slab, and then we'll need one sidewalk segment for both the end approach slab transition and the end approach slab asphalt overlay segment. So we'll quickly run through those now. Go back up to the place barrier tool, We're going to change the template name for the transition segment because this is no longer going to need the additional thickness because there's no asphalt overlay portion. So we'll just click on left sidewalk for the transition segment and click select. We shouldn't need to make any changes to any of the other inputs. We will already have our feature definition set to sidewalk. The cut orientation should be follow skew for both of those, and the barrier material should carry over from the previous sidewalk placement. So with all those placed, we'll now click on our transition segment for the begin approach slab, and we'll right click and left click one more time. So we'll select from guideline. We're going to select 0.5 again, click OK. You'll have your check mark there and say OK. Once again, we'll just need to go in and update our variable constraint there. So we'll set the sidewalk width. We're going to be running now from approach slab 1 transition support line. Change these both to 11'1". And click OK. So now our approach slab sidewalk is complete on the begin approach slab. And you can see that here in our 3D view. So the last sidewalks that will need to be placed are at the end approach slab. I'll quickly place those now. Should follow all the same inputs as the previous transition segment. And the only thing we'll need to do is update the sidewalk width. And then the last sidewalk, we'll just need to use the Flex AP template again, because we will once again be on an approach slab overlay segment. Everything else should be the same. So we'll go ahead and click on our approach slab, continue, select 0.5 again, and click OK. We'll update our width one last time, and then we will have our sidewalks all completely placed. And now here's what the final end product should look like for the approach slabs with sidewalks. So for the final portion of this exercise, we're going to be placing the barriers on our approach slabs. This is going to be very similar to exercise 5.5 where we place the barriers on the deck. However, it's a little more involved trying to keep track of which templates need to be used on which portions of the approach slabs. Due to the portions of approach slab with the asphalt overlay, we will have to use different barrier templates at that portion versus the transition portion that will accommodate that extra 1 3/4 inch thickness, similar to the sidewalk templates. So we'll get started by going back to our wireframe, and then we can start placing our left barriers. All of our left barriers are going to be 32-inch vertical face barriers that will be placed directly onto the sidewalk components. Because they'll be placed on the sidewalks and not directly on the approach slabs, we can use the same template throughout all portions of the approach slab. So we'll start by going to the Place Barrier tool, and we'll have to revise all of our inputs. So to start, we'll select the correct template. So we'll go to the ellipses here. Once our template selection window opens up, we'll navigate up to the barrier folder, go to FDOT. We'll widen this window here a little bit. And then we're going to navigate over to our 32-inch vertical shape barrier. Now we remember it's going to be our left barrier, so we'll select vertical shape L. And as I mentioned, this will be placed on the sidewalk, so we don't have to worry about the flex pavement template. So now it's also important to note where the working point is when we're placing barrier templates. You can see it's at the gutter line. So we'll just have to be aware of that when we're choosing what our horizontal offset is from our guidelines. So we'll go ahead and click select. And now for our 32-inch vertical shape barriers, those are going to be 1 foot 1 inch wide. So that's what we'll set our horizontal offset to. We want that right gutter line to be placed 1 foot 1 inch away from the edge of the deck. So that's what we'll choose, 1 foot 1. We'll update our barrier material to be the barrier pay item. So we're going to the 32-inch vertical face. That's going to be 521.54. So click on that and then click select. Next, we'll confirm our start and end cut orientations are going to just remain as follow skew for all of our left barriers. So we'll leave those as shown. And then the last thing we need to do is update our feature definition. So we'll change that from sidewalk to traffic railing. Now that we've done that, we can select our candidate. Go ahead and click on the sidewalk there. And then right click to reset and left click to continue. Next, we'll select the guideline from list. And we're going to pick our leftmost portion of the template. So that's going to be 0.5. Click OK. And click OK once again. And now we've placed our first barrier on the sidewalk. We can take a look at that in our isometric view here. Returning back to our wireframe, we'll place the remaining barrier portions. So now we'll start placing the barriers on the remaining portions of the sidewalk here. I'll open up the place barrier tool again. And everything is going to remain the same. We're going to use the same template throughout. It'll be the same horizontal offset, same barrier material, cut orientation, and feature definition. So we can go ahead and select our candidates now. I'm going to select our begin approach slab transition segment and our end approach slab transition segment. We can select multiple candidates as long as they use the exact same template. Unfortunately, our last sidewalk has a different template than the transition ones, so we'll have to do that in a separate selection. So with our two transition sidewalks selected, we will right click to reset and end selection, and then left click to continue. We're going to select guideline from list, and we'll choose our leftmost point, which is going to be 0.4. Click OK, and click OK. And now you can see that we have our two barriers there. So finally, we'll place our last barrier on that final segment of sidewalk. So all of our inputs, once again, will be the same. We'll click their sidewalk, right click, left click to continue, select guideline from list, and choose 0.5 is going to be our leftmost point. OK and OK, and that will finish off our barrier placement for the left side of the bridge. Next, we're going to place our right barriers. So all of our right barriers are going to be 42-inch single slope barriers. Now for these barriers, we will need to change the templates because we're going to be placing the barriers directly on the approach slab, meaning we'll need to account for that additional 1 3/4 inch thickness that's missing on the asphalt overlay segments. So we'll start at the beginning of the bridge. We'll go back to our place barrier tool. We're going to change our template name here. And we're going to select, as I mentioned, the 42-inch single slope barrier, the right one. And since it's on the beginning of the bridge, which is the asphalt overlay segment, we're going to select the single slope R Flex AP template. Once again, note where the working point is. It's going to be at the gutter line. So we'll use that as our horizontal offset. We know that the width of a 42-inch single slope is 1.5 feet, but we'll need to make sure that it's placed to the left of the edge of the deck here. So we'll have to do -1.5 foot offset. Next, the barrier material needs to be changed. We're going to match the 42-inch single slope barrier. That's going to be 521, 514. Select. And then we will update our cut orientation. So because we do have a deck break back on the right side here, the start will have a normal to path cut orientation, and the end cut orientation will remain as follow skew. We'll leave the feature definition as a traffic railing and click our candidate here. Next, we will right-click to end selection and left-click to continue. Select our guideline from list, and we're going to choose the rightmost template point. So that's going to be point 1. Select that and click OK. We'll click OK once again, and we'll place our latest right barrier there. So next we're going to place our barrier on the transition portion. So we'll go to place barrier again, change the template. Remember, because we do not need that additional thickness on the barrier, so we will select the single slope R without the Flex AP. So just 42-inch single slope R. Click select. Our horizontal offset will remain the same, so will our barrier material. We do need to update the cut orientation. So the start is going to match what the end was on the previous segment. So that's going to be follow skew. And our deck does have a break back at the front here, so our end cut orientation needs to be normal to path. So with that now selected, we can choose our candidate, which is going to be the approach slab segment there. We'll right click to reset, left click to continue, click the guideline from list, and we're going to select point 1 once again and click OK. Once we click OK one more time, it'll place that additional segment right there. So we'll flip over to our isometric view just to get a quick look. And everything looks good. We can see that the top is lining up correctly. So we made sure that we've placed the correct templates by having the Flex AP on the asphalt overlay portion and then the standard template on the transition portion. Okay, so the final bit of this is going to be to place the barriers on the end approach slab. So we can quickly go through that. I'll go back over to the wireframe view and place these 2 final barriers. So I'll open back up the place barrier tool. We're going to use that same template. No change necessary because we're still on the transition segments. All other inputs should be the same here. So we have our horizontal offset, barrier material, and feature definition are all the same. The only thing that will change is our cut orientations. So for the first one, it will be a start cut orientation is normal to path because we do have a break back there, you can notice. And then we're going to follow the skew on the end cut orientation. Okay, so with all those inputs selected, we'll click our transition segment again, right click, left click, select guideline from list and point 1. And then our final barrier segment will be using the Flex AP version of the template. So we'll go back to 42, single slope R, flex pavement, select, change. Won't need to change any of these top inputs. We can leave our barrier material the same and our feature definition the same, just change our cut orientation. So our start will be follow skew, end will be normal to path because we have our deck break back there, and then we're going to select our approach slab. Right click, left click, select guideline from list and point 1. And we are all set there. So now we can take a look at it in our isometric view. I'll quickly kind of rotate around here a bit, and we'll see that we have placed all of our approach slab segments, our sidewalk segments, and our barrier segments. That will conclude exercise 5.9, the last exercise in chapter 5 of the Bridge Modeling Training Guide. Thank you for watching this section of the training series for FDOT Connect. Additional training videos and course guides are available on the CAD Office Training webpage, which can be found at fdot.gov/CAD.